Hello student, we are going to start with the chapter electricity. The first topic which we are going to cover, that is electric current. Now the first thing we have to understand, what is the meaning of current? We have heard about air current, wind current. Current means to flow. Current means to flow. Here electric, electron. That means electric current, the simple thing as the name suggests, that is flow of electron. Right? We'll enter into the chapter, then we'll understand about this flow of electron, how it happens. Before I start with the electric current, conductor and insulator. What is conductor? Through which the electrons, through which the heat or electricity can pass. Insulator, through which it cannot pass. बचपन से पढ़ते आ रहे हो. Now the thing is conductor. Conductor, in which, and mostly the conductors are made up of metals. Now again, what is the relationship between conductor and metals? Last year you have studied in 9th section that what are metals. Metals means losing of electron. Non-metal means gaining of electron. Metals have free electrons to move. Like here, this is how free electrons metals have. So valency of metals are always positive. Positive means to lose. So, when I am talking about conductor, I am talking about the metallic wire. Metallic wire. And the best conductor is silver and copper. Silver will not use because the valence of silver is 1. This is the best conductor, but it is quite expensive. Copper wire mostly we are using in our domestic circuit and all. So, copper has the valency of 2 positive. That means losing of electron. Right? Suppose this is the wire. This is the wire from which we can see the electrons are moving in positive charge. It is flowing. It is flowing from positive to negative end. Right? Now positive means lose, negative end should be there because it is gaining this electron. And as soon as it gains, we'll call it as a current. Very simple. Now what is circuit? What is circuit? Electric circuit means it is a closed or continuous path through which the flow of electron passes. Clear? Flow of electron moves on in this closed and circular path. Cross section may be triangle, may be square, and suppose this is rectangle. Right, student? So, flow of electron. Now, in physics, when I am talking about current, I am talking about charge. Charge means number of electron. Charge means number of electron, which is represented by capital Q. Clear? So, now we will not call it number of electron because together it is known as charge. So, flow of charge is there and there must be some time taken. That means time should be there. Charge, these are the two conditions for the flow of charge. Now, the comeback here. Now, what is current then? Before again, we have to discuss about the cell. Now, I am saying that positive to negative. Now, when I am drawing these two ends, one is longer line and another one is smaller line. One positive and one negative, and this is the conductor wire, right? So, this is known as cell having two terminals, one positive and one negative, right? When there is more than one cell, then we will call it as a battery, right? How many cells are there, student? 1, 2, 3. So total 3 cells are there, which together maybe kitne marzi ho sakte, so many cells could be added together, but this is together when it is there, then it is known as battery. And battery we are considered with a volt, 6 volt, 10 volt. This is how the battery is represented. Now, next is, what is current then? What is current? It is the flow of charge in unit time in any cross-sectional area of the conductor. Clear? Again I am repeating. What is current? Current is represented by capital I, Q, charge, T, time. Now what is current then? Final definition. It is the flow of charge in unit time in any cross-sectional area of the conductor. Simple. Now, next is, what is unit then? What is the meaning of unit? It is representing the numerical value. It is also representing the physical quantities which can be measured, right? Now, the unit of current is 1 ampere. The unit of current is ampere. After the name of the scientist, Andre Marie Ampere. I'm repeating, Andre Marie Ampere. So what is 1 ampere then? Charge, the unit of charge is coulomb, again after the name of the scientist coulomb, and T representing the second. So what is 1 ampere? Same definition. Here I have used charge per unit time. See how I am using here. What is 1 ampere? It is the flow of 1 coulomb of charge in 1 second. Very simple. In any cross-sectional area of the conductor. Students, again I am repeating, what is 1 ampere? It is the flow of 1 coulomb of charge in 1 second in any cross-sectional area of the conductor. When we start with the numericals, again 1 milliampere will come. What is the meaning of milli? Milli means it will be there in the numerical. That means we have to add 10 to the power minus 3 ampere. If I say 1 microampere in the numerical, then it will represent 10 to the power minus 6 ampere. Right? Now, and this is how current is described like this. And next, that is how the current can be measured. Current is measured by using ammeter, A-M-M-E-T-R, ammeter, which is measuring the current. And it is always arranged in series combination. What is series? When we are adding it into the same wire, that means here, suppose here, this is ampere. Okay? This is ammeter, positive and negative. So this is how the same wire, when we are arranging this, then it is known as ammeter, right? To measure the current. Now the next topic, current. It is the flow of charge in unit time, right? What is conventional current then? Very important. What is the meaning of conventional, student? To make use of it. How we are using this current in our daily life. Now in our daily life, what we are using here, where the current is used? To glow, bulb, tube, CFLs, fan and all this, fan to run fans and all, gadgets, so many different gadgets we are using this current for this. But if I say only the flow of charge is current, that doesn't make sense, because electric current, until or unless we are not using it, there is no sense of electric current, right? When we are using it, then now suppose if I say I have added one bulb here, I have added here. Now this is the bulb I have added, right? Now positive to negative end, it will not glow. When positive to negative, the flow of charge reaches, then only the current will flow. When I am talking about conventional, now electric current is positive to negative. Current is positive to negative. But conventional current, if I am talking about conventional current, that means it is negative to positive side. When it reaches here, then the conventional current goes, and it is just opposite to that of electric current. Clear? This is just the difference. It is opposite to that of the electric current. Current is from positive to negative, and conventional current flows from negative to positive direction. Clear, students? Now next, numerical point of view, this is the last, how we'll attain the numerical here. Now suppose if I say, for example, some question is there, the 2 coulomb charge, okay? Suppose if I say 2 coulomb charge is flowing and taking the time of 20 seconds, right? Find its current. Find current. So which formula? I is equal to Q upon T. So what is Q? 2 upon 20. So what is the answer? 0.1 ampere. Right? Right, student? This is how we are finding the current. And if we crisscross this definition, Q is equal to I into T. Right? Now what is Q? If I want to find the number of electron, this is again the problem. Now finding the number of electron, the another formula which we are using, N is equal to Q upon E. Right? So Q is equal to number of electrons. So N is equal to Q upon E is to find the number of electrons, and 1 electron charge is equal to 1 electron charge is equal to 1.6 into 10 to the power minus 19 coulomb. This you have to learn. 1.6 into 10 to the power minus 19 coulomb. Right? One last recap. Again, I am going to start. Electric current. It is the flow of charge, right? Flow of electron. When I am talking about current, the first thing we'll talk about the cell. Cell, it has one positive terminal and one negative terminal. When more than one cell is used, then we will call it as a battery. Now, what is circuit? Circuit means it is a closed or the continuous path through which the charge flows, right? Now, what is current then? It is the flow of charge in unit time across any cross-sectional area of the conductor. This is switch. When it is dot inside, that means closed. If it is open, this is open, that means now the current is not flowing. Right? This is how we are representing. Next is I is equal to Q upon T. Right? And the unit of current is ampere. Ampere, what is 1 ampere? It is the flow of 1 coulomb of charge in 1 second. Right? So, ampere is equal to coulomb per second. And this is how we'll go with the numerical. Very easy. Just putting the formula Q is equal to I into T or I is equal to Q upon T. These are all crisscross method. We are going to frame these formula ourselves. What is the requirement of the numerical? That we'll see to it by seeing this. Clear? And we know number of electrons is equal to Q upon E. So, Q is equal to N into E. Clear, student? If there is any doubt, you can ask me in my comment section. Clear, student? Everything is clear? Next topic will start with potential difference. Right? Thank you so much.